and so this last lesson in the unit and the chapter is about just using exponents, and really the lesson's about looking at a variety of different problems that involve exponents. I just have one example here, so please don't think this lesson is about volume and surface area. But the formulas for volume and surface area of a sphere do involve some exponents. And so the volume of a sphere is 4/3 pi r cubed, where r is the radius of the sphere, and the surface area of a sphere, that means the surface that covers the outside of the sphere, is 4 pi r squared. All right, so with that said, what is the coefficient, base, and exponent of each of these formulas? Well, let's look at volume first. Which again, I said is 4/3 pi r cubed. The coefficient is everything being multiplied to the power. In this case, it's 4/3 pi, all of that together. 4/3 times pi. All of that is the coefficient. So in this case, the coefficient is a mix of a rational number and an irrational number. But that's OK. 4/3 times pi, all that together is the coefficient. The base is just the r. That's what's being repeatedly multiplied. And the exponent is the 3. So this is the same as 4/3 pi times r times r times r. And remember, the word power is, if I were to ask what the power was, the power would be r to the power of 3. All right, so for surface area. The coefficient is the 4 pi. The base is just the r again, and the exponent is the 2. And if I were to ask, the power would be r to the power of 2. That's the power. And again, so this means 4 times pi times r times r. And maybe I'll write those both up here. All right, so let's just use these to determine the volume and surface area of a marble. Looks like I have a marble right there with a radius of 6 millimeters. So if I look at this diagram here, I'm saying from here to here is 6 millimeters. So what's the volume and surface area? Well, first, volume is 4/3 pi r cubed. In this case, the radius is 6 millimeters. So 6 cubed. And the surface area is 4 pi the radius squared, so 6 squared. And at this point, it's a matter of just evaluating. Order of operations, you probably want to go 6 to the power of 3 first, which is 216. So I have 4 over 3 times pi times 216. For surface area, I have 4 times pi times 36. Now at this point, I'm just multiplying a variety of numbers together. I have, if I want, I could multiply all these together first. 4/3 times 216. Put all my rational numbers together. And which is the same as, we looked at how to multiply fractions, reviewed how to multiply fractions earlier in this. So if you want to do that, you can use a calculator. You can think of it as 216 over 1 and go 4 times 216 over 3. Whole bunch of ways of looking at it. In the end, that should come to be 288. So 4/3 times 216 is 288. So all that's times pi. Once I actually decimalize pi, my answer is now rounded. So if I do this times pi, however many decimals I see in my calculator is an approximation. So I'll put a little dot over my equal sign. But I'll say it's approximately 904 point, I'll round to 2 decimal places, 78. And the units is millimeters cubed. There's the volume. And so surface area, I'll do the same thing. I'll first just multiply my rational numbers together. 4 times 36, and that gives me 144 times pi. And as soon as I go 144 times pi, and I have a decimal value, it doesn't matter how many decimals I keep, it is an approximation. So it's approximately 452.39, I'll round it to. and this is millimeters squared because it's surface area. I will say, in later courses, it's actually, you're encouraged to leave your answer the step before. For example, for surface area, 144 times pi, we could say just that's our answer. And that's maybe a bit weird to understand, but that's a perfectly good answer, 144 pi millimeters squared. Or for volume, 288 pi millimeters cubed. And sometimes your calculators may just give you a value like that. That value there is what we call the exact value. It's perfectly good, but it's probably easier to understand the decimal approximation. And keep in mind, again, the purpose of this lesson is definitely not about surface area and volume. It's about working with exponents. And these two formulas definitely work with exponents a bit.